How do we start with this, guys?
Good morning.
Good morning. You're fine. What do we do first on this one? What do we need to do first when we have subtraction? What do we do? Yes, yeah, distribute that minus sign. I need to take this minus sign and distribute it into the parentheses. This first set of parentheses isn't actually doing anything for us, so we can just kind of drop them. They're not making any changes. So this is going to be 7b squared plus 6b minus 7, and then we have our minus 4b squared plus 2. So we've got to distribute that minus sign through first. Then what do we do? What can I do to simplify this? Yeah, so we're going to have our combining like terms really is what we're doing, right? We're combining our 7b squared minus 4b squared, combining the 7 and the minus 4. So 7 things minus 4 things will leave us with 3 of those things, 3b squareds. 7b squared minus 4b squared. I don't have any other b's to put with it, so we're going to put our plus 6b. And then we've got our minus 7 plus 2.
Pardon this interruption. Just
Gives
a
us
reminder
minus
to
5.
staff, this is a no testing first period day, but you do have the rosters for today and tomorrow. Testing starts third period today. Thank you.
That is the default state of first period. Okay, so that's our answer right here. Combining things together. On our second setup here, our parentheses aren't actually doing anything here because they're being added together. So what we're doing is we're just going to be combining our like terms. So these parentheses aren't actually doing anything. The only thing in here that's weird is when I take out these parentheses, we've got plus negative 2, which is the same thing as having minus 2. So these parentheses aren't actually doing anything. So we're just combining our like terms here. So again, I've got our minus 2f squared minus 2f squared, which gives me how many? Minus 4f squared. Remember, with our negative numbers, sometimes it's easier if we think of it as somebody owes me money. If I owe you $2 and I owe you $2, I owe you $4 together. Same thing with if I owe you $3 and I owe you $3. Grand total, I owe you $6. Thank you, dear. And then our last piece on here, our minus 5 and our plus 8, which is going to give us a plus 3.
You stuck to the desk today.
I did. They're really not talking today, the iPad and the computer. So I'm having to manually flip the pages on the computer and then adjust the screen over here. So I need the mouse significantly more often than normal. That's not what I meant. There we go. Ah! Hang on, trying to get it back. There we go. Sideways, but we got it. All right, any questions on the part of the screen that it captured? Got a chunk of it, not the entirety of it. I love it. It's so much fun. I tried to take the picture of it, and it then deleted everything. They're in such good moods. Oh my gosh, this is so fun. We love this. It's the bestest ever.
They woke up and chose violence.
Very, very much. And actually, I think they just got into a fight overnight because they refused to talk to each other. They both refuse to talk to the Google Drive as well,
Oh.
which is so much fun. All right, so let's get into what we're doing today, which yesterday we did adding and subtracting. Today, we're going to do some multiplying.
Yeah.
So we're going to take a polynomial and multiply it by another polynomial. Sometimes we will multiply by monomials. Sometimes we will multiply by other numbers of nomials. But we're going to do some multiplying today. So if I didn't tell you that this is polynomial multiplication, what would our instinct be if we saw something like this? Parentheses E with a thing out front. Distribute. It's exactly the plan. Just because we magically say it's a polynomial does not change what we do here. We're going to distribute it. So this first one, it's 2x times parentheses 4x cubed plus 5x squared minus x minus 7. Bless you. I'm just giving you guys a second to write it down. So whenever we have a monomial out front that we're multiplying by a monomial, so one of those one-piecer things, I don't care how many pieces are in this polynomial. If we got a monomial out here, it's distribution. That's all we got to do. We're going to distribute it. So when I do it, it tends to get really arrowy, but that's okay. I'm just trying to make sure it's clear what we're doing. So we're going to take our 2x times 4x cubed. What is 2x times 4x cubed?
8x power 4.
Yes, 8x 4. 8x to the fourth. We don't have a special word for fourth power like we do square and cubed. We just say to the fourth power. Because the Latin-y stuff gets really weird after that. It does technically have a word, but it's just weird. All right, so our next piece that we're going to do, we're going to take our 2x times our 5x squared. So our plus sign comes down. 2 times 5 gives us 10. And x times x squared gives x to the third. Where these are coming from is the fact that our x has a power of 1. If there's no exponent here, it has a 1. And what we're doing is we are adding 3 plus 1 gives us 4. 2 plus 1 gives us 3. So that's one way to think of it and how we're getting these numbers. Or I can think of it as x times x times x. X, x, x. There's 3 x's there. All right, so let's do our next piece. 2x times minus x. And I have minus what? Gorgeousness. 2x squared. One more piece. I've got 2x times minus 7.
14, negative 14x.
Minus 14x. That is our answer. We cannot combine pieces any further. I've got a whole lot of things that have x's here, but remember, x's, x squareds, and x cubes, they're related. They're all from x's, but again, that's like having an apple tree, an apple pie, and maybe an apple donut. Do not put an apple tree in my apple pie. It's going to mess with the texture. I do not want to eat bark. So they're related. They're all from similar things. And using some manipulation, we could make them all work with each other. But I cannot straight up take an apple tree, put it in my apple pie, and say, look, I have a thing. Aside from a monstrosity. Okay, so we can't combine with the different powers together. Questions on this one? Because I'm going to have to do a check-in on every single page in order for this thing to actually save stuff for me. And actually, no, I'm just going to scan my documents when I'm done. Okay. Because once I change pages, I can't go back on this particular setup because they're so grumpy. All right. let's look at our next one. I have to clear the stuff. Boop. All right. So then we're going to look at what happens if it is not a monomial that we are multiplying by. Okay. Oof. So here's our next two that we're doing. The first one should look real familiar. Hi. Thank you. The first one we've done before in previous sections. We've done things like this. And there are a few ways of doing it. You can either do this with the box or you can do this with distribution. Both are valid. Both are right. Neither is better. It does the exact same thing. It's just whichever works for your brain better. On this first one, I am going to do both at the same time so we can see what's happening. It's doing the exact same thing, but it's just going to like make us see things clearer. So if you are somebody who likes to box multiply, we put our box with our little pieces. We break it into pieces like this because I have 2 pieces here and 2 pieces here. That's where these guys are going. So we would have our 3x plus 5 and our x minus 7. So if you are a box multiplier, this is how you set it up. You could absolutely switch this piece for this piece. It does not matter which side you make which side. We're just doing the thing. So whether you like to box or you like to distribute, we're going to wind up with the same pieces that we're multiplying. We're going to multiply our 3x times x. 3x times x gives us 3x squared. If you're in the box, you're putting it here, 3x squared. I'm going to take my 3x times my minus 7. That gives us minus 21x. Minus 21x. Then we've got to do the same stuff with our 5 over here, because I need to take both of these things times both of these things. So we're going to take our 5 times the x to get a positive 5x plus 5x. And we're going to take our 5 times our minus 7 to get minus 35. So whether you do it with our distribution or putting it through the box, you wind up with these exact same pieces that are all being added together. As a reminder, if you are a box person and you forget what operation it is, there's a little secret plus hidden here in the middle of the box to help us remember. Everything gets added together, which would get you exactly back to here. So when I say it does not matter, it does not matter. Both are right. We have one last step to do down here before we're done. What do I need to do on this thing? Simplify. What can we simplify? These guys. I have some like terms here. So minus 21x plus 5 is going to give us what? Minus 16x. So we have our minus 35 here and our positive 3x squared here. This is our answer. Nope. Okay. Questions on this first one? Just giving us a dividing wall here. It's not different on the second one we have here. It's just instead of a binomial and a binomial, we have a trinomial. It's got 3 pieces and a binomial. We will not often ask you to do ones this big because these get really, really big really, really fast. It's going to happen, but not super duper tons. But then I'm looking at our notes and saying we're going to see it several times a day. So it doesn't really change what we do. Again, you can do this with the box or you can do it with distribution. I do tend to do it with distribution just because the box tends to take up a lot of space. But if you want to do it with the box, the only thing you need to change is instead of doing it as 2 by 2, I need another set. So it would have to be a 2 by 3 box. So we would have our x plus 2 and our 2x, ooh, there we go, 2x squared plus 3x plus 5. And then you do the exact same thing. You multiply the pieces in, you add them up, we combine like terms. Totally fine. I just tend to do it distribution-wise because it takes up less space. So we're still going to wind up with the same things. I'm going to take my 2x squared times x, and that's going to give us what? 2x cubed. We're going to take our 2x squared times 2, and that's going to give us 4x squared. Ooh, I got to write a little smaller. I'm going to run out of space. We're going to have our 3x times x, which is going to give us 3x squared. Then we're going to do our 3x times 2 to get 6x. Then we're going to take, we're down to our 5. I'm going to switch to the bottom because we're running out of space. We're going to take our 5 times x. And our last piece is going to take our 5 times that 2 to get 10. I know. It helps me not get overwhelmed choosing colors if I use the rainbow. Otherwise, there's too many options and all I pick is purple, blue, and pink. What I do, my natural instinct, so I try and make sure I get the warm colors too. Okay, so we multiply everything out, and then we need to simplify and combine some like terms here. So I have in here a couple of sets of like terms. We have a couple of x squareds. So my 4x squared and my 3x squared, that's going to give me a 7x squared. We're going to have my 6x and my 5x, which will combine together to give me 11x. And then our other two pieces just kind of hang out. So my 2x cubed is chilling, and my 10 is chilling. There's nothing else we can combine together. All I have here is apples, apple pies, and apple trees. Can't combine those together. And that's our multiplied piece here. Okay. Questions on either of these two? Okay. So a lot of times we'll be given things where we have two things to multiply like this. Sometimes things are going to get a little crazy. And I'm going to give you a slide that does not want to show up. There we go. 3 things to multiply. So we're going to put 3 things together here. So I have 2x plus 5 times x minus 3 times 3x plus 2. And what this is going to be is we're going to do 2 rounds of multiplication. We're going to do 2 sets. So when we multiply, if we think through our order of operations and we do our PEMDAS stuff, when we get to that MD, multiplying and dividing, that happened in the same set, we go left to right. So first we're going to multiply, a pen that actually shows up, these two pieces together. And then we'll take whatever, where's my laser pointer? There it is. Whatever we get from here and multiply it times this. So we do it in pieces. Don't try and do all three at the same time. You will get it wrong because it changes our order of operations. So we're going to have to do it in two chunks. So we're going to multiply those two together first, which means the first thing we're going to do is our 2x times x, giving us 2x squared. And I am going to put this set back into a set of parentheses. We're going to be in a set of parentheses here. Then we're going to take our 2x times minus 3 to get minus, Then we're going to take our 5 times x to get plus 5x. And 5 times minus 3 to get minus 15. This thing is still here. Our 3x plus 2 is just hanging out over here. And you could, if you wanted to, plow forward and go from here to do your next set of multiplication. But it will make your life easier if we combine our like terms on my x's, where I have my minus 6x plus 5x. So combining our like terms together, we're going to have our 2x squared minus x minus 15. And that's what we're going to multiply against the 3x plus 2. So again, you can do these with the box or with distribution. I just did these with distribution because they take up so much dang space. If I do the box and my screen is grumpy enough as it is, I can't make it give me more room. So on this one, we're back into exactly what we were on the last one, where we have our 3 times 2, so it's going to have our full rainbow on the colors. So we're going to take our 2x squared times 3x to get 6x cubed. We're going to take our 2x squared times 2 to get 4x squared. We're going to take our minus x times 3x to get minus 3x squared. We're going to get our minus x times 2 to get minus 2x. We're going to take our minus 15 times 3. Might have to use our calculator on that one.
-45x.
Minus 45x. And then our last one is our minus 15 times 2 to get minus 30. One last step. We got to combine our like terms in here. So the pieces that have like terms are our squareds. So 4x squared minus 3x squared. I'm just going to leave. Oh, you said something at the door. Sign says knock like you mean it. You did not listen to the sign. So we're going to have our 6x cubed plus x. It says knock like you mean it. I heard nothing. That was the whisperiest knock ever. Like I think you just waved at the door. So we've got our 6x cubed, our x squared. We got another set of like terms here. We've got our minus 2x minus 45x, which gives us minus 47x. That's I owe you $2 and I owe you $45, so I owe you $47. Minus 30. Okay, do we see where those pieces are coming from? Any questions on these things? This one's our biggest one so far, for sure. Okay, they don't get worse than this for us. Like, these are the biggest ones we're going to do, is the 3 like this. Okay, so let's do another one. We're going to do another one just like it. One more time. This will be the last one we do, okay? So, again, I can't come back to it once I clear it. So, questions on this one? All right, I'm clearing it. Boop. And here, this one's last one. Same vibe. We're going to take and multiply our left 2 pieces together and then multiply it against the right piece. So 3x minus 4 times 2x plus 3 times 3x minus 2. And we're going to start with our left 2 pieces. We're going to take these 2 guys and multiply them together. So we're going to start with our 3x times 2x, giving us what?
6x squared.
Then we're going to take our 3x times 3. 9x, good. Here's some of us starting to wake up. I love it. And we have our minus 4 times 2x. And our minus 4 times 3. Our other piece is still just kind of hanging out. Don't lose track of it. He's just chilling here. We need to combine our like terms. I mean, we don't have to, but it is significantly easier if you do. So I highly, highly, highly recommend it. You can do it right without doing that, but you're just going to have so much more to combine on the last step. So we're going to combine our like terms together. So this is going to be our 6x squared. 9x minus 8x gives me 1x, or just x. You do not have to write the 1. For some people, that's really helpful. For some people, it's not. I tend to switch back and forth because, again, for some people, it's helpful, and for some people, it's not. So I try and make sure I hit both edges. And then we get to do that whole process again, getting all of these pieces to multiply against these pieces. And I put those very close together, so I'm going to wind up overlapping a bit here, but that's okay. So then we're going to take our 6x squared times 3x. 6 times 3 gives us 18. And x squared times x is x cubed to the 3rd. So if doing the individual multiplications is a sticking point for you, that's a way to do it. Multiply your numbers, then multiply your letters. So we're going to take our 6x squared times the minus 2. So 6 times minus 2 is minus 12. And the x squared doesn't multiply against anything, so it just stays x squared. I'm going to just start on the bottom now because I'm running out of space. 1x times 3x. 1 times 3, well, that's just a positive 3. And x times x? X squared. Good. I heard it. It was quiet, but it was there. Then we're going to take our 1x times minus 2. Negative 2x. This one's probably going to be our biggest number of the day, where we take our minus 12 times 3x.
Negative 36.
Negative 36. x. And then our last piece is our minus 12 times minus 2,
24.
a positive 24. And we're almost done with this. What do we need to do next? What's our last step on these?
Combine like terms.
Mm-hmm. I have a set of like terms here with my x squareds and here with my x's. So when we're combining these together, we're going to get, I'm trying to find a color I haven't used. Let's use this. Our 18x cubed, our minus 12x squared plus 3x squared is going to give us what?
Negative 9x squared.
Negative 9x squared. That was this piece just because we used a different shade of gray. Then we have our minus 2x minus 36
Negative 38x.
minus 38x. And then we have our plus 24. And that's our answer, that 18x cubed minus 9x squared minus 38x plus 24. Okay. Questions on that or that bit or what we do or our multiplying or any of that jazz?
Do you have another homework?
No, that's the back side of the homework from yesterday. So I'm not giving you a new homework. What I'm going to do is I'm going to pass back the skills check. So you can have that. Okay? So I'm going to clear this off unless anybody objects. We got 3, 2, 1. All right. You can finish up 4-3. I am going to pass back your skills checks. You can see those, see what we got right, what we got wrong, and all that jazz. And then, yeah, if you got questions, feel free to stop me and ask them while I'm going around. But you get the rest of the time to work on 4-3 and check over your skills check. You do get to keep your skills check. That's fine.